is really to review the architectural patterns that we see with serverless. It's going to be a review of many different architectures, different things, especially seen from the customer perspective, right? So what are customers doing in terms of serverless? I'm Adrian Hornsby. I'm technical evangelist in the same team as Danilo. I didn't write the book, unfortunately, so I cannot show up my books. Yeah, I've been using AWS for about 10 years, 10, 11 years now almost. And I've been with AWS for 2 years. I started as solutions architect and moved to transition to a technical evangelist role a year ago. So I worked a lot in architecture. That was my job for about 10 years. So that's why I love kind of that topic. This is what we're gonna try to learn and talk about today, is really understand some of the key concepts in serverless. I'm gonna really go fast to that because in a serverless track, usually everyone goes through the same things. So I'm gonna try to skip some of the things and really talk about the relevant concepts that are for architectures especially. Then we're gonna go through event processing, pipelines, and architectures, operations, web application, and finally data processing. Data processing, in fact, is pretty much the biggest use case of serverless, right? Even though most people start with Lambda function with API gateway because of the framework like serverless and things like this, but in terms of customers and how they use serverless, data processing is massive. So it's very important that we look at it both from a Kinesis point of view, so streaming data to the cloud, and also from an IoT point of view, what are the things that you get when you send data to the cloud with IoT. All right, so let's browse through some of the key concepts. If you don't see behind, just raise your hand, say grow, I'll just push up the stuff. I try to make the slides so that they are okay, but you know, you never know. So there's so much light here, so it's hard to get some contrast. But make it interactive as well. If you have some questions, just raise your hand. If it's a hard question, I'll just ditch it politely. Thank you. For me, we've seen these slides all over again, but the most important part today, and especially for the architectural part, is this one, right? The fact that when we talk about serverless applications, is that we have availability and fault tolerance built in, right? And that really is the strong thing of serverless, is that you do not have operational burden, right? This is what we want to take out of your hands, so that you can focus on having a good run for the business. You know, focusing on your business logic and application. Do not have to worry, manage infrastructure, scale it. So that means two things. That means that you need to figure out, understand what are the services that really go into that spectrum. And when we talk about serverless, these are the services that really stand out in terms of taking the operational burden out of your hands, right? And especially, of course, we all know Lambda, because this is pretty much the service that started this serverless revolution. But Kinesis is extremely massive, and S3 is the foundation of it, right? If there was not be Amazon S3, this pretty much wouldn't be any serverless. Because let me tell you a little story. We launched AWS Lambda, and AWS Lambda was thought simply to add compute to S3, right? Nothing else. So the idea was that when you put an object into storage, our customers would want to do some processing on it. For example, uploading an image, extracting metadata, EXIF, or have a document and say take the size of it, do some conversion. This was the only use case we had in mind with Lambda when it was started, right? And if you know a little bit how AWS works, we work backward from customers, and in fact, an overwhelming part of our customer feedback was, well, we want to use Lambda for everything else, but that. Even though it's used a lot for Amazon, but basically for Amazon S3. But customers have opened really the use case of Lambda, so that's why it has exploded in what it is now. And it integrates with a lot of services. DynamoDB as well, extremely important. Right? And the next question is, why are those very important, and why do they have fault tolerance built in? This is the reason. When we talk about regional service, and the serverless services are usually regional service, if not all of them. This is what we talk. We are saying that each of the regional services are actually sitting on top of 3 AZs, right? And in my next talk, I'm going to talk a lot about availability and reliability and why this is important. But if you can imagine in a region, this is a region, for example, Dublin has several AZs. If you have a problem in AZ, which is an availability zone, where your data is sitting or your application is there, then you still have your service running on top of 2 others, right? So AZs for us are the unit of availability, right? So when we talk about serverless services, especially regional services, this is what we mean. And this is why fault tolerance and availability is so important, right? Because if you wouldn't have that, and you would have to manage the high availability, you would have a lot of work to do, right? So this is something that, for me, if you think about serverless, is the most important thing to remember. Another thing which I want to talk quickly is, because this is something I saw that a lot of people have questions even about it, is when you talk about a Lambda function, there's 3 things to remember. The handler is just the name of the function, right? This is how you're going to call it. Then you have the event object, which is passed as the first parameter of the function. The event object is an event that is passed to the function to execute. So say you have an object that you push into S3, it creates an event, new object, and you pass that to a Lambda function. My event will be the name of the object, the name of the object, the name of the bucket, the time of creation, right? And then the context is the context on where the Lambda function is being executed in the infrastructure, right? So that would be the region, that would be all the information that is the runtime, the programming language support, all these kind of things that are important for you to extract to run your Lambda function, all right? And it's also used for log groups and request IDs. And this is very important because we always talk about events or context, and sometimes it's a bit of a misunderstanding. You've seen this slide. I think pretty much everyone in this room was in Danilo's session, so I'm not going to deep dive on that because Danilo explained very well. Those are the main differences, right? That we have synchronous and asynchronous invocation of Lambda functions. Synchronous invocation is me, I'm calling it, and I'm waiting for an answer, right? If it's asynchronous, it means I call it and I go away. Eventually, I will receive a notification with an ID of that I can query to get that result. So there's 2 ways of invocating that. This is very important, especially for Kinesis and DynamoDB and how we're going to process the stream. The second part of the presentation today is a lot around this. So understanding that when we push events in a queue, an ordered queue, is very important. Couple of best practices as well that are relevant in that context. The most important, I would say, separate your Lambda function from the core logic, right? So all your database initialization, all these things, do it outside of the Lambda function so that they are initialized and they can be reused, like database pools and connection pools especially. Use environment variables to modify things and to pass data that is mutable between different functions. So say, for example, you want to query a bucket, S3 bucket through a Lambda functions. Do not hardcore the name of the S3 bucket in the code. Really pass it as an environmental variable at execution time. Self-dependencies, right? So we, of course, have an environment where you can execute Lambda function and test them, right? So in this environment, so when you go into the console, you can already write code and import, say, OS, sys, and use the AWS CLI, which are kind of libraries that are by default in the platform. But when you go in production, do not use that. Bring in your own libraries. Always bring your own libraries because otherwise, you have a dependency on us, right, to maintain the versions of libraries you were using. So say, for example, you are using a library for doing, let's say, OpenCV, right? This is for doing machine learning. So you're using OpenCV, so you do an import OpenCV, and your code is dependent on version 1.7. And there's an API that is only available on 1.7. If you don't ship it, and we don't support 1.7, we support 1.5, then it's not going to work. So always when you push your code, bring your own dependencies, right? And all the code, all the libraries that you're using. It doesn't mean that you should bring the entire set of classes. For example, if you use Java, the entire set of classes to your Lambda functions, because you're going to end up with Java Lambda functions with Java that are over half a gig. So only use the things that you need. Right? Also very important is do leverage X-ray. X-ray is a phenomenal tool to understand what is happening. X-ray is used from the SDK, from the client, and then it basically attaches an ID to all the requests that is happening on the AWS platform. And it's an ID that you can use to build graphs. On the UI, you would have dependencies graph like this, which would tell you the amount of requests that have been successful, the amount of requests that have been unsuccessful, but especially that will give you a time that it took for the Lambda function, say for invoking an S3 bucket, for putting things into DynamoDB. So it's a very good way to visualize problems in your pipelines, serverless pipelines. And it really, in Lambda, it takes just one tick to enable it, so really do it. And this is the way you would use it in your code, is basically wrap the middleware sampling rules on the entire SDK, right? So you wrap the X-ray around the SDK. So it's very similar to do monkey patching of the things. These are kind of the exam graph you can get, and you see this is when you would query an S3 bucket. You would have the dwell time and then the attempt, and then you can see here the difference between here and here. The execution is simply what people call the cold start. Right, so you probably have seen that and heard about this as well. So the cold start is the first initialization of the Lambda function. That means that when you call Lambda with the first time, we need to deploy an environment on where we can execute that Lambda function. That means, and it's a containerized environment with your programming language that you support, the libraries and the code. Right? So it takes different time, whether you use Python or Java or C# or Go, but it's something that you need to be aware of. Usually Python is very fast, GS is very fast as well. Java is much slower because we need to start the JVMs and things like this, but those are the things. There's a bunch of frameworks that you can use. I'm a huge fan of the serverless framework because this is where I started the thing, but I slowly move as well to SAM, right? Because, and in fact, pretty much everything I do now, I use SAM or CloudFormation because it integrates very well. I used CloudFormation a lot before, but when we went serverless, there was it was a bit complicated to write everything in CloudFormation. And if you are interested and you are good at, say, Express.js, for example, there is directly a code on the AWS lab that you can start using to deploy your Lambda functions both with Express.js as well. So interesting things. A call out also to Zappa, which is pretty great, to be honest. Sparta is a Go framework. It's pretty good as well. A lot of stuff. So let's take a look at the first set of architectures. And event processing is really the kind of the initial idea, as I said, how we wanted Lambda to be used, which was get an event from an S3 bucket and process it. So an event-driven is, for me, the world runs event-driven, right? When I talk to you and you answer to me, it's event-driven. You do not ask me all day long information, right? We are waiting for events to happen. So I really like this paradigm, especially for software development. So For Lambda, it's really simple. There's an invocation, and whether you do it synchronous or asynchronously, and then there's an action. Nothing more complicated than that. And the good thing is we started with S3, but now there's a bunch of services that integrate and are able to pass events to Lambda. And Lambda then further is able to query and pass that event to pretty much anything, right? Because you can write your own code there. But it integrates very nicely with those services natively. And the first event, as I say, was that S3 bucket event. So when you put, for example, an image in an S3 bucket and you want to resize it, that's a genuinely good use case for Lambda, because if you had to build resizing or thumbnailing systems 4 or 5 years ago, it usually had the machine sitting idle, and then you would have to query. But the problem is there's an EC2 instance running, just waiting to execute a few times on the day, the thumbnailing and the resizing. And now really it's like just happen when things really move in the S3 bucket. So this is really a genuinely good way of using Lambda function to trigger S3 event. And in fact, you have lots of different events that you can get from S3, but this is one of the best use case. Resizing image, or you can extract information, metadata. I'll show you a demo about how you can extract and convert everything with step functions as well. There's a live demo at the end. The second thing is, which happened very fast, and this is for really event-driven, but it's already related to big data. You're probably aware of Amazon S3, right? Amazon S3 is the storage that we use and our customers use extensively to store both very hot data that you want to use on a daily basis, or very cold data, archive data. So there's a way for you to move the data in different tiers from hot to cold, right? So S3 has become the de facto standard to store data on the cloud. But the big problem was that when you store data, is that there's a lot of dirty data, right? You need to clean it, you need to process it, you need to verify that the content that your, for example, customers are uploading is valid. So for example, if you have an application and your users uploading videos, you don't want people to upload runnable or executable code, right? So you would have a way here, for example, a Lambda function to verify that everything which is pushed into a S3 bucket is valid, is content that is not tampered with, that it's not dangerous, or that all this kind of stuff. So this architecture and this model has become very, very popular, right? Where we would have a staging layer and then the production validated layer. And in fact, you can have many different layers, or you can fan out as well. It's a very expandable paradigm, but nonetheless very, very, very useful, especially if you go into big data and you want to clean the data. Say, for example, I upload JSON files, and then you would have your system querying directly the JSON file on the S3 bucket. There's a lot of moments where you might have malformed JSON data, and that will crash the systems, right? So very good use case is for each of the JSON objects that is pushed into S3, you have a validation layers that actually make sure your JSON object, for example, is well formed, so that it doesn't crash the rest of the thing. Or you can do computation, combine object, change the format. So this is very, very important pattern used by overwhelming number of customers on AWS. If you want a little bit more complex use of event, we launch step functions, right? A step function is very simple. It's a way to orchestrate the execution of Lambda function one after another in parallel or in series, right? So say that it's a state machine, right? Put it simply, it's a state machine that you can control with an API. You can start and stop, right? And then all the different execution nodes are Lambda functions. And you can then tie them together to execute your code. So let's show an example, and this is a live demo I'll do. this is an application that will run on my local machine. I'm uploading a photo into S3, and then I have a Lambda function that will start a state machine here, step function, initialize it and start it. And the step function will do three things. It will extract information from the object, so the metadata, EXIF, and all this kind of stuff. It will start converting and generating thumbnails, and then important thing, it will also call recognition. And if you don't know what recognition is, it's an artificial intelligence service that we launched a year and a half ago, or yeah, something like that, that allows you to extract information from image, like scenes, objects, so you get tags, automatic taggings of your images. So very, very powerful services. But let's look at that. So this is how my application, my Node application runs locally. It's very simple. Do not look at the UI. It's terrible, but it's not, the way it should be. And say I'm uploading a photo like this. The upload is going to happen to S3. S3 will trigger a Lambda function that will trigger the step function. So there we go. The uploading of the photo is done. The Lambda function is executed. It's already returning the step function execution ID. And then that's pretty much it. And then I have my photos here, which I uploaded, the tag extracted, and its thumbnail. So it's a very powerful way of creating serverless architecture. And in fact, that pattern that I just explained here is, and especially the second part here, that one, is extremely useful for indexing large amount of data that you have in S3, right? So you could have, for example, a Lambda function here that introspect all the content that you have in S3 bucket and start to invoke the other Lambda functions. And we have customers that have done that, index the entire set of images they had, or videos as well, because now recognition supports video, so you can extract metadata from videos as well. So very nice, clean use case. And again, the good thing is it's highly available. If you have an issue on the availability zone, the system will still run. If you don't use it, you don't pay. The only thing you pay is here, content sitting into S3. And if you have content into DynamoDB, let's say it will be DynamoDB, but now you can actually scale down DynamoDB automatically to 0. So that means it's going to be very, very cheap to use those. And event-driven, so it's just, in my opinion, it's pretty beautiful. The second patterns that we see a lot, and Danilo also mentioned those, are in operation. And I would even go to say that they were made very, very popular by Netflix, right? They have something which is called Trust But Verify, and this fits very well into those architectural patterns. And in fact, what they do is they use a particular thing in Lambda, which you can invoke Lambda like a cron job. So that means that you can set up a schedule, say my Lambda function has to be executed every 15 minutes or every 30 minutes, once a day, this kind of stuff. So that you can have Lambda automatically replace any of the cron job you have. And that's pretty cool because you can also, in fact, define the scheduling the same way you define cron job with the same cron job syntax. And those are kind of the different things you can do. I'm going to show a couple of those patterns here. And one of the, I think, when I talk with customers in the last 2 years, and especially also when I used AWS, the biggest problem we had is knowing what belonged to whom, right? So we were a lot of people working, and then people started instance, and they were not tagged, they were not named according to conventions, and then 2 weeks after, it's like, what is that? Right? And so taggings are great, but the thing is humans aren't. So it's very important to automate tagging, right? And a pattern like this is very, very useful. That's a pattern that uses CloudWatch event to detect when a resource is being started on the platform, right? Most of the resources that you can start, for example, if you start an EC2 instance, generate an event, which is run instance, start instance, stop instance, terminate instance. All those are passed as an event to the entire platform, which can be caught by CloudWatch and then pass on to Lambda to be executed. And this is exactly what happens here, is if I'm starting an instance and I forget to tag it, I still have my identity, right? Because I started the stuff and I logged in, I used an API which had my credential. So I have something called the principal ID, which represents the ID of myself. And when you have that event being broadcasted to the platform, it's passed in this event JSON object, right? Which is, it passed the principal ID of who started the resource. So you can catch it and then add it as a tag to the instance. And this is very, very good, because it means if you forget to start resources, and it always happens, especially in test, or just when you start playing at the beginning, then you end up with tons of resources that you don't know what they are. And we are always often scared of stopping things we don't know what they are, right? So this saves a lot of trouble. Another pattern which is very similar, and this was done by Capital One, and there's you can access the entire documentation, and they open sourced it as well. It's called Cloud Custodian, and they do very similar things on different levels. So they catch CloudTrails, CloudWatch events, and then they use the same pattern to enforce rule and compliance. So for example, if you start an EC2 instance and you don't have the right version of kernel, the system will automatically detect, send a notification, or even you can force it to stop the instance, right? So you say, oh, this EC2 instance actually doesn't have the last security patch. Let's stop it automatically. This is a very good way to prevent things from running in your environment that are not compliant with your policies, right? And then send notifications about it. So this is very interesting thing. And this is exactly the pattern as well that Netflix does with Trust but Verify. They allow pretty much any developer to start resources, but they have Lambda functions that automatically check that everything which is started is according to compliance, the right version of libraries, the right version of security patches, the right versions of everything, right? The right security group, the right keys, all these kind of things that you don't want to manually check. And it's very easy to enforce at account level and even as a group of accounts, so in organization. And lastly, as I said, you can schedule your backup. And this is a very good pattern, for example, for organizations that require more more regular backup than, for example, the default backup. So in Redshift, you have default backups every 15 minutes, if I recall. And some customers need to have more backups, so every 3 minutes. So you would have these kind of things enforced through a Lambda functions. You can use the same pattern for your databases or DynamoDB, all this kind of stuff. Simply the pattern is very powerful. Again, in AI, something that has started to pop up a lot is this pattern. And Poly, actually I can demo quickly. Do you know what is Poly? No, cool. Let me demo you quickly so that. Poly is an AI service that converts text to voice, right? So for example, and I'll do it in Swedish because it's easier for you. But did you hear anything? Oh, let's do it. The projector doesn't work, so I'll try to change that.
Hejsan. Jag heter Astrid och läser upp det som skrivs här.
No. Did you hear it? It's good? Ah, cool. So that's Poly, right? So, and it's very simple to use. It's a new AI service that was launched, again, a year and something ago, a year and a half at the previous reInvent. And it's very powerful because you can send any text and it will return you an MP3 or a stream of the audio. And people have started to use it very extensively, especially in the asynchronous mode, so that every time you push new data into a website, for example, or you create automatically a podcast. Right? Washington Post is starting to do that. There's a lot of different customers. Duolingo is the app that you can learn languages, is using Poly to synthesize all the voices. So it's very popular thing to schedule, for example, AI job. And I just use Poly as an example, but it could be recognition, it could be any other AI model that you have in mind. And if you're interested, there is the code available on my GitHub account as well. You wanted to take a photo? All the slides are going to be available offline. Do not worry. Most important is to tweet everything. That's the most important. Just tweet all day long. Another pattern is the ops automator. And this is also a pattern that has been published in our website. And this is a general patterns that you can take and optimize for your personal use case. And this is how it would, it can work, but it's a one-click deployment, and then you can just affect the different resources that you want to monitor, the execution and things like this. But it sets up the entire project for you with one click and explains how to modify and tune it for your use cases. All right. This is where it is as well. The next pattern, which is of course very popular, and we've talked about it, is web applications, right? And as I say, API gateway, or as Danilo said and showed very well, API gateway is kind of the foundation to being able to do that. Because by default, an API, a Lambda function doesn't have an API endpoint, right? So when you want to query a Lambda function from the internet, you need to give it an API endpoint. Therefore, you need to use an API gateway. Right? And now we have the proxy method, which by default will just take any request and forward it to the Lambda function, which makes it very easy to use Lambda functions with API gateway. So basically, this is how a classic web app would look like. And if you remember the one I had on my computer that I did the demo of very similar use cases, I have an S3 bucket with CloudFront distribution to serve the content, the static content, so all the images and videos, and then you have the dynamic content coming from the Lambda function. So people and customers have built entire websites using that pattern. Yes, there's a question already. Yep. Sorry? Yep. In VPC, you mean? Yeah. So you can have a VPC endpoint now with your Lambda function. So your Lambda function can be executed in a VPC. So that's entirely possible to do it like this as well. So you will need a VPC endpoint for your API gateway. So in practice, no, because currently API gateway doesn't support VPC endpoint. Right. But here, your Lambda function can be queried within the VPC, and then you would have fan-out options there. Right. It's not as clean as what you would want to have an API endpoint within a VPC, right? And the default way of securing access to those API is really Amazon Cognito. If you don't know what Amazon Cognito is, mission for today, really have a look at it. It's extremely useful service. It allows you to do pretty much one line of code or 2 lines of code to do authentication in any of the services, right? So it's very nicely used. There's, especially now that we support user pools, so you can have all your users stored in our Cognito user pools and then manage authentication like this. And it works, I'll go back to this use case, but it works like this. You have your browser, basically. All the static content would be protected from CloudFront. You can use either geo-restriction, you can use signed cookies, signed URLs for all the content that is stored into S3. S3 support very strong encryption, both with your own keys or with KMS service if you want to encrypt the data there, and you have two ways of securing your bucket access through either policy or ACLs. And then the API gateway, as Danilo said, supports the throttling through APIs, caching, and of course user plan if you want to monetize your API. And then all those are using IAM roles. So the security is very well defined across the entire spectrum. And again, this is how Cognito works, is especially through a custom authorizer here, but your client requests a Cognito ID. So whether you want to use SAMLs or OpenID connects like Twitter, Facebook, Google, they will give you a token, which then you can pass to the API gateway, and then API gateway will use a custom authorizer to verify that you are really the one making the request. Right? So this is a very classic standard way to authorize APIs to your API gateway. Yeah, you have two types, whether you pass the token or then through the request with header parameters and stage variables as well, query strings. Something that also I will talk more, I have a full session on that and dwelling into reliability, availability, especially for deploying multi-region infrastructures. Now API Gateway supports regional endpoint, right? So as Danilo said, initially when we launched API Gateway, there was a CloudFront distribution attached to it by default, and there was no way for you to get out of it. That means that you were limited by especially using a custom domain name. It was not easy to integrate Route 53 to it, or it was actually not easy, it was impossible. So now we support custom domain name. That means that your API does not have a CloudFront distribution in front of it anymore. So that means that you can now use Route 53 to do CNAME routing, right? So, and there's a lot of different routing policy that we'll go through the next presentation if you're interested. But for example, latency-based routing, there is failovers, there are regional, and things like this, a few others. So it's a very interesting way now of using it. The next pattern, what the happened? The next pattern I want to talk about, which I think is very important, is the data processing architecture. Right? And here we're going to start with the Kinesis-based apps. But first I want to talk a little bit what we mean by processing real-time, and especially what's the processing pipeline. And usually it's like this. You have ingest, you transform the data, you want to analyze the data, react on it, and then persist it. Right? So, and many of those stages need to have storage, right? So what's the default storage that we use for data processing? Woo! So basically in the entire foundations of all the architectures that you will see around data processing, S3 is going to be there because it has a lot of capability. And if you remember the staging and the production bucket, basically you would have pretty much a bucket for every stage here. Right? Because every stage takes power, takes energy, they compute, right? And you don't want to waste that. Right? So that you can always go back to the previous stage. I always say, always store the raw data, because you cannot recreate it. Right? And as I said, also, S3 supports 3 tiers, 3 classes: the standard, the infrequent access, and the glacier. And this is really for how hot is your data. So if your data is really hot, that means you're using it a lot. You would want it to be in standard. If you don't use it too often, so like a couple of times a month, or you would put it in infrequent access. Why? Because your costs are reduced by half. And then if you don't use it, you would use it, you push it into S3. And what we realize actually across many customers is access pattern of data goes like 30 days. So very active now. Then at 30 days, it reduces almost 50%. 90 days is almost gone, zero. It doesn't mean it applies to everybody. It means in general, having an idea that the data that you store in your organization doesn't have to reside all the time in the most active and hot storage, right? You can access the data as fast as you want. You can access the data here as fast as you can in standard. It's just that it costs a bit more. So that we leverage the number of access versus the speed. So if you don't have data that is accessed a lot, do not keep it in the standard. And those are the different class of things where you would want to store the data. The second thing, especially because we're talking about Kinesis, is understanding what Kinesis is. Right? Just to get an idea a little bit of the audience, how many of you have used Kinesis? Great. All right, so like 20%, 30%. So Kinesis is a streaming service, as easy as that. What is streaming? If you look at the motorway, this is the streaming. Right? You send data to the end of the road, and the end of the road is the cloud. There's no way back. There's only one way. And the number of lines is how much you can send the data, right? So if I have a line, each line has a maximum bandwidth, for example, 10 cars per second. If you try to put 20 cars per second, it's going to be a traffic jam, right? So every time you want to send more data, you need to increase your stream, right? And we call that a shard. I'll go through that. This is how it looks like. So in a motorway, if you increase your bandwidth, what we call a shard, then you will need to create another shard. So that you can allow more cars to be delivered. And this is the raw version of Kinesis. It's called Kinesis, right? That means that as a user, you need to manage the shard and the way they are spread across Kinesis. And one thing to remember as well is a shard supports 1 megabyte write, 2 megabyte output. And this is for a simple reason that you want to be able to empty the queue, right? Because if it would be 1-1, and you're at max, you would always never have a queue that would reduce, right? So this is classic. And in terms of vocabulary, we use producers. Those are the components that are sending data to Kinesis, and then consumers, the one that consumes. And as I said, it's a regional service, so it's by default sitting on top of the availability zone, right? So if you would have problems on the AZ, the system, the service will still be running and delivering your data to your systems, for example, to Amazon S3 or any other stuff. And there's a second flavor of Kinesis, which is called Firehose. And this is the managed Kinesis in a way that I have my line, and the system automatically increases the size of the road without me telling it. It just detects the number of cars and say, oh, now there's more cars than I can send. I'll just increase the size of the road. So that's what it does. It manages the number of shards. So it's a very good way if you want send but forget. And this is what I like. The only problem is we only support delivery of data to 3 things like S3, Redshift, and Elasticsearch. Right? So it gives you a little bit of it's the trade-off, like whether your consumers have to do the job or you let the service do it. I personally love Firehose because I love sending all my data into S3, and then I've even triggered from there. Makes life a lot easier. Let's go through a demo, and this is the architecture of the demo that will involve every one of you. We're gonna have you're gonna access a web page with your mobile phone. Each of the mobile phone will be sending data to Kinesis, and then I have a service called Kinesis Analytics, and I'll explain what it is after the demo. What it does is takes a window, time window, and does some SQL queries on top of it in real time, so that I can have some computation in terms of understanding what is in the stream at this moment that I'm querying, and then deliver that information further down the stream, push it to Dynamo, and then I will have a dashboard to visualize all that. So please, come with me, and let's break the Wi-Fi. Let's pray that the gods or demos are with us today. I do not guarantee anything. I do not have SLAs on my demos, unfortunately. But this should be working very nicely. So quad@orn.me, right? I haven't put the SDK in your apps. Yeah, sorry, buddy. I have a little limited amount of time, but it's a good idea actually. I should definitely do it. It's a very good idea. So this is what you should see, right? At horn.me, and this is basically how the things look like. So let's go. And this is so we have currently like about 80 users on the systems using the thing. So let's see. So the data is sent in real time, and in fact, it's sent into US East, Kinesis. There's analytics running, then sent to another Kinesis stream, sent to DynamoDB, and my dashboard queries that dashboard, that DynamoDB table, right? So let's do a test. Everyone goes onto the A, right, with your mobile phone. See how fast it takes. So already we see a huge increase. Up. So a couple of seconds, right? It was 5 seconds. There's still some rebellious kids there on B. Send of them. Who are you? Danilo, stop. So it's just an example of how fast the streaming pipeline is. Right? When we're talking real time, it's pretty much near real time. So imagine you're a business and you want to calculate real time the effect of the news that you put out there on Twitter. Right? You could see it almost in real time. Or that you want to do A/B testing, how your users are using the platform at the very moment when you start using it. It's extremely powerful, right? And what if I would tell you that it's serverless? So that if you don't use it, nothing is going to be paid for, only the data in S3. That's it. All right. So this is how it looks like. You have the slide so you can look at it. But just quickly, this is what your mobile app is sending. It's sending a JSON object, which has a bunch of things. The most important thing is the Cognito ID. And the Cognito ID is unique for every one of you. As soon as you downloaded the app, there was a JavaScript library that went query Cognito, get that ID to make you a unique user on the service. You didn't have to authenticate, realize, because Cognito support unauthenticated scenarios, right? Where I have strict policies and say you are only allowed with that Cognito ID to send data to Kinesis stream and this particular shard. So this is the data that is being sent to JSON object. And then Kinesis Analytic, actually I'll show you because it's much more fun to show demos. And you see it's not prepared here. Because I want to show you quickly something. The application. All right. Yeah. Okay, now the next thing is to know where in which region I am. Okay, maybe I don't show it right now. I should have prepared that part. Let's go there, because you don't need this. I have everything in the slide. This is how the Kinesis Analytic things work. I have an application that takes that JSON object and tries to make a data representation of it. So it's just very similar to a database, right? There's two concepts that are important in Kinesis Analytics, especially the SQL queries. When you run the commands to access the data that is being sent to Kinesis, is the stream, which is very similar to a table. The only difference is like a table, running table, right? That's why we call it the stream, is because it's never with persisted data, right? You have only maximum number of data is 1 day. Right? Then you access you define the parameters that you want to access to, right? Very similar to how you would create a database. And then you create a pump. A pump is simply take the data, put it there, like so, exactly what a pump does, takes water from one place, put it to another. And this does the same, right? It takes data from the table that, on the stream, and then push it into another distinct table. So you can create lots of different cascading pumps, each of those pumps doing some data transformation, right? This, how you would insert different distinct record in the stream. So you notice here, I have a different access of the data per second on my SQL stream, and then for each of the streams, I calculate per second the number of OS, so iOS, Android, all these kind of different things. I count them on this, and then I also count the number of people that are on this quadrant. Quadrant is where you were on the UI, and that's it. And what it does is it groups them in two different ways. This is the way you can do this in Kinesis, what we call the windowing. Either you have a moving window, or you have what we call the sliding window here, or a tunneling window, which always stays the same, right? So the data goes like X-ray at the airport, right? Instead of having the X-ray following the stream. And the output of the Kinesis stream happens like this. When I've computed everything, I push that into another stream, Kinesis stream, which delivers the data or that Lambda function queries on that stream. And there's one shard, so there's basically, that's how Lambda can access the data. And then Lambda stores it further to DynamoDB. So it's a very simple way to create very powerful application serverless way. And important thing to remember if you start using Lambda with Kinesis is you have one Lambda dedicated per Kinesis shard, right? So if you have 10 shards, you need to have 10 Lambda function processing each of the shards. And this is one of the most important thing to remember. And it's the way the Lambda invokes the shard to get the data is every second. That's it. Every second we are getting the data from the shards. Right? So you have to tune your Lambda function like this. A second use case that is very good, especially using Firehose, that I also published on my GitHub, is a Python project because I just like Python. But what it does is instead of writing the logs on the file, it sends JSON objects of each of the events that happen in my application to a Firehose Kinesis stream, S3, and then Athena. And in a couple of seconds, I have all the data queryable into Athena. Athena is a really interesting service. Again, it's in the serverless IDs that there's no servers to manage, and you can create tables or database tables of data sitting on top of S3. Right? So it's a very, very powerful way of querying data that is in S3. You don't have to transform it. You can query JSON object, Parquet files, and a bunch of other stuff. And it works like this. This is the screenshot because, oops, how do I do the growing the magic trick you did? My fingers don't work. This is how you would do it to create your, this is the data, my JSON object that is in S3. You see the location here. When you get the slide, you'll be able to get that. And that's pretty much it. Then you can start querying your data, and you see I have all the events that have happened. So it's a very good way to start querying your API logs, and especially when you think about applications which have hundreds or 200 microservices, each of them putting to log file is very difficult to do this kind of stuff. So this, in my opinion, was a very, very easy way to do, first to remove all the logs, then I don't have to deal with files, but especially then being able to have aggregation of all my APIs near real time. The second use case, and we're going to do a couple demos. we have 5 minutes still to go, but this is data sensor collection, and this is very important use case, right? IoT is there. In fact, IoT, the AWS IoT service is as well a very scalable system. It's resilient by default, so it's a regional service, sits on top of 3 ASICs, so it's very interesting and easy to use. What it does is allows you to connect 1 to millions of sensors, sending data to IoT. And IoT service will scale without you having to do anything. And the 2 things that are important with IoT is rules and actions. Rules is, what do I do with my data that is coming to the platform, or what data do I take from there, and then the action is, what do I do with it? Right? So for example, if I have a JSON object of temperature, humidity, all this kind of stuff, what I want to take from that is just the temperature, for example, and then send that temperature somewhere else. So this is the action. And this is very classic patterns of doing that, where you would have similar applications what we were using, sending to Kinesis, but then integrate with IoT. And IoT integrates very nicely with Kinesis, right? So you can, from the actions, select the Kinesis stream to forward the data that is being streamed by IoT devices in the cloud. Gives you a lot of capability, the same way we've done that. One of those is, for example, to do anomaly detection. And this is a classic example of using Lambda to do machine learning on data that is coming in real time. Imagine you would have a sensor that is monitoring, for example, the vibration of a particular engine. If you have change in the vibration pattern, this is the kind of things you want to detect and notify people of. And this is the pattern that is used for. Let's make a last demo before closing. This is just to show you how fast and easy it is to use. IoT platforms support MQTT over WebSockets, so you can do pretty interesting things if you start to do web apps. And this is what I want to demo there. And here, everyone is going to go again to the URL. You're going to have an image, and I'm going to control that image remotely, because this is how I believe things should be done. So that opens a bidirectional channel between you and me. Hopefully it will scale. It should fail. I did the demo with 400 people, and it went very well. So it depends, of course, of the network. You got it? Good? I'm so impatient. I hear this all the time. All right, good. All right, cool. So you should see something like that. You have the wrong URL, I guess. That had horn light bulb bitly. Does anyone have it? Ah, cool, good stuff. Whee. Demo gods are still with us. That's the last one, so before the next one. So I'm pushing a little bit. It's good. All right. So this is what you should see. And here, you should all see connected to Lightbulb. Can you give me a thumbs up? You have connected? Good. It means we have a bidirectional channel between you and me. That means that I can start controlling you like that. So let's see if this works. So I'm going to increase the light bulbs. Right? So 5 what? How about now? 17, 44. How fast is it? Good. So this is very, so again, it goes from my laptop to US East, IoT, comes back, a new query. So it's pretty interesting, and the power of it is MQTT, right? MQTT is a protocol for sending very efficiently over even very bad condition network. So this is the kind of things you can do. And let me get another thing, because it's always good to close the demos with something even more fun. But you can query. The good thing is, maybe you notice in this architecture, this little baby here, this is Alexa. That means that Alexa you can have an Alexa skill that runs a Lambda function, and then you can query it. Luckily, unfortunately, I don't have my big Alexa here because my girlfriend doesn't allow me to take Alexa out of the home. But I have an emulator here. So, Alexa, ask Lightbulb to set the brightness to 20%. So it's invoking the skill. There's a cold start. Right. My God, the demos are. This is. Let's push it even further. Alexa, ask Lightbulb to flash fast. There was some problems. Okay, but still. All right. But this is the kind of things you can do with data and pipelines. And the interesting thing to keep in mind here, there's no servers to manage, right? So imagine I'm a startup and I want just to get my idea out there. Serverless patterns are extremely useful. But bear with me, right? It doesn't mean you should do everything with serverless. It's not a magic hammer that you should use for everything. I thought you have questions like, should I use Lambda for pretty much everything? It's not, right? There's limitations. And when you design architecture, it's really understand your use case and test especially, right? And see where the limits are. And do not just make the decision of using serverless or Lambda or stuff like this because it's fun. Make it because it's important. It's the most important. There's tons of reading, especially the white papers. It's a field that is growing, serverless. And also one thing, do not always associate serverless and Lambda because you can have Kinesis, totally serverless, IoT, totally serverless. It's just a combination of being highly available. And this is really the most important thing to take away. And again, there's a full part dedicated on website for it. So thanks very much.